Welcome to The Explainer. I am so incredibly thrilled you're here today because honestly, we're looking at a topic that is fundamentally reshaping how we think about agriculture, energy, and construction. Today, we're exploring the massive, highly lucrative business potential of industrial hemp. But we aren't just talking about any hemp. We're looking specifically at a new wave of highly engineered Ukrainian varieties. We're going to see exactly how science is turning a simple crop into an absolute industrial powerhouse. Okay, let's dive into this. It sounds like a total exaggeration, right? I mean, can a single plant actually replace imported natural gas in standard concrete? Well, when you look at the immense macroeconomic stakes of the modern energy and construction sectors, the answer is a resounding yes. We are way past the days of hemp just being used for ropes or artisanal textiles. What we're talking about today is a highly scalable green industrial revolution.
Think about the number 20 for a second. That represents the astounding 20 tons of total biomass per hectare that these specific hemp varieties can produce in just a single growing season. For anyone tracking agricultural investments or bioeconomy inputs, that number is staggering. It completely outperforms a lot of traditional biomass sources, and it manages to do so with far fewer demands on the soil and the environment.
Now, yields like that, they don't just happen by accident. They're the results of a 90-year scientific legacy. Over at the Institute of Bast Crops in Hlukhiv, Ukraine, they started this continuous hemp growing experiment way back in 1931. Through the Second World War, the rise and fall of the Soviet Union, right into Ukrainian independence, they kept growing and studying this plant on the exact same plot of land. That rigorous, unbroken history proves to investors that these crops are remarkably stable. In fact, in 2022, on that very same 90-year-old plot, they set a record of 15 tons per hectare of just the stem yield alone. No way, right? And for commercial operators, this next metric is absolutely crucial: 0.0. Both of the specific varieties we're profiling today boast exactly 0.00% THC. This isn't just some fun botany trivia. This is a zero-risk legal guarantee for your business. When you're running a massive processing facility, you literally cannot afford legal friction, testing delays, or regulatory hurdles. Absolute zero THC means frictionless processing across borders. Section 1, Hlukhiv 51, the fiber champion. And this brilliantly illustrates exactly why G51 is causing such a massive stir in the industry. Let's look at the plant meticulously bred for the heavy-duty demands of the construction and textile industries. Standard European varieties often hover around 25% fiber content. Even a highly respected high-yield European legacy strain like Hungary's comparative sits at around 34%. But Hlukhiv 51 hits a world-leading 38.9% fiber content. It has this extreme bast cell morphology, which basically means the physical layer of the plant holding the fiber is exceptionally thick. So what does that world-leading fiber percentage actually translate to in the real world? It translates to incredibly specific, high-margin revenue streams. Because of that thick, bast layer, G51 is ideal for hempcrete, a sustainable, highly insulating building material. It's perfect for technical textiles, industrial canvas, paper, and even advanced automotive biocomposites, where European car manufacturers are using natural fiber mats for door panels and dashboards. G51 is effectively a factory in a field.
Section 2, Hlukhiv 85, the energy giant. Okay, so what if your goal isn't building materials, but actual power? Enter our second titan, the only Ukrainian variety exclusively engineered for the bioeconomy and the energy sector. Instead of focusing solely on fiber length, G85 is designed to maximize total biological mass, up to that incredible 20 tons we talked about earlier. Let's break down the return on investment here. From a single hectare of that biomass, you can generate 3,000 to 5,000 cubic meters of biogas. Alternatively, dry and compress it, and you get 5 to 8 tons of dense heating pellets. Or you can process it down to 3 to 4 tons of pure cellulose for the paper and bioplastics industries. To truly grasp the strategic economic power here, think about this conversion rate. Just 1 ton of these hemp pellets provides the heating equivalent of 500 cubic meters of natural gas. I mean, for local municipalities, factories, or entire regions looking to break their dependence on expensive, imported natural gas, this is a real game changer. You can literally grow your winter heating fuel in your own county during the summer.
Section 3, European head-to-head comparison. Let's walk through the hard data to see exactly how these stack up in a highly competitive global market. When you compare G51 and G85 against heavyweights like France's Futura 75 and Finland's Finola, their specific strengths are pretty obvious. The Ukrainian strains vastly outcompete their EU counterparts in pure straw yield and fiber percentage. Now, actually, if your absolute only goal is harvesting hemp seeds for oil or food, Finola is your winner. It practically doubles the seed yield of the others. But for industrial fiber and raw biomass, the Hlukhiv strains completely dominate the board.
Now, beyond just the raw yields, there's a massive operational difference at play here, and it all comes down to plant biology. You might be wondering, why does plant sex matter to an investor? Well, legacy varieties like the Hungarian compulti are dioecious, meaning they're distinct male and female plants. They grow to totally different heights and have different harvest times, which makes mechanical harvesting an absolute nightmare. Both Hlukhiv varieties, however, are monoecious. Every single plant is genetically identical in sex, guaranteeing you an evenly leveled field, perfectly uniform mechanical harvesting, and a consistent product for the processing plant. Which brings us to a really core strategic difference in breeding philosophy. European varieties have largely been bred for the standardized, highly regulated, and relatively mild climates of Western and Central Europe. They kind of require highly specific conditions. The Ukrainian varieties, born out of that 90-year experiment, were bred for harsh continental climate resilience. They thrive in lower input agricultural setups, fighting off weeds and surviving temperature swings that would quickly stunt other crops. Now, what's really interesting about this is how that climate resilience translates directly to risk management. Look at the days to technological maturity. The French bioenergy variety Futura 83 needs over 150 days to mature. In a continental climate, that pushes your harvest deep into the freezing, rainy autumn, completely ruining the crop. G85 achieves its massive biomass in just 103 days. You sow in spring, and you safely harvest long before the autumn rains even arrive. You're effectively mitigating your weather risk by a month and a half.
Section 4. Strategic Value and Local Economics. Let's move on and see how this builds into an incredibly fast business cycle, connecting agricultural metrics to massive local economic impact. It's basically a 100-day field-to-heat model. Step 1, you sow your G85 seeds in late April. Step 2, let it grow for just 103 days with minimal intervention. Step 3, harvest up to 20 tons of raw biomass per hectare. Step 4, you immediately dry and pelletize it. Just like that, within a few short months, you have completely secured a community's winter heating supply from the ground up. And you know what? Running that 100-day cycle is shockingly cost-effective. Both G51 and G85 have earned perfect 9 out of 9 scores for resistance against major threats like fusarium disease and the stem borer pest. This absolute pest resistance drastically cuts down the need for expensive chemical inputs like pesticides and fungicides. Lower chemical costs mean a significantly padded profit margin for both the farmer and the investor. It's a win-win. The source material for our explainer today actually wraps up with this incredibly powerful statement. In the context of restoring destroyed energy infrastructure, at a sufficient scale it replaces imported gas. This isn't just about farming anymore. We're talking about the geopolitical and reconstructive power of agriculture. It's about empowering entire regions to grow their own energy independence and rebuild infrastructure using hyper-efficient green materials. So, what does this all mean? The crucial point here is that the future of industrial materials and local energy is literally growing right from the ground up, in a fraction of the time we used to think was possible. The science is proven, the legal THC risks are zero, and the yields are breaking records. So the only question left to ask yourself is this: which variety will fuel your next industrial venture? Do you need the structural power of the fiber champion or the raw output of the energy giant? I highly encourage you to dive deeper into these commercial hemp opportunities. Thanks for joining me on this explainer, and I'll see you next time.